Okay, so can I start? We started probability yesterday. Yes or no? So write it. Probability of okay. Probability of A or B. Okay. So I'll explain what is this. So for any two events, A and B, okay, P of A union B equal to P of A plus P of B minus P of A intersection B. So note for independent events, for independent events, P of A union B is equal to P of A plus P of B. Now what is that? I'm going. Do you have some idea about intersection union? Do you notice you have some idea about it, union symbol? You type you notice? Okay. Done? Okay. Sorry. Let's write one more note. Note 1, note 2. I think you know this. Probability of not A. That means we write probability of either is equal to not E. Probability of either is 1 minus P of A. Can I start? Can I start? So is it okay? Can I go to the next? Okay. I'm giving an example, then you write. Number 1, probability of solving a problem. Probability of solving a problem by A. A is a student independently is 3/4, comma, probability is 3/4, whereas probability of solving the problem the probability of solving the problem by the student B independently is 1/4. Now if the probability of solving the problem if the probability of solving the problem is 1/16 when they both try together, then find the probability that the problem is solved. Find the probability that the problem is solved. Okay. This is the question. I repeat, probability of solving a problem by A is a student independently is 3/4, whereas probability of solving the problem by the student B independently is 1/4. If the probability of solving the problem is 1/16, when they both try together, then find the probability that the problem is solved. Can I start? Okay. Now, one thing you see, this is the probability of solving the problem by the student A independently. Independently means alone. Alone by the student. Suppose this question only. When this problem is given to you, one of you can do this question independently by your own, not by taking help. So independently alone, the probability is 3/4. Whereas the another student B, if he tries, the probability of solving by him independently alone is 1/4. Getting it? These are their independent probability. That means if the student A tries alone, the probability of solving this problem by that first student is 3/4. By the second student alone is 1/4. Now, if they both sit together, okay, the problem will be solved, and for that the probability is 1/16. Now the question is, find the probability that the problem is solved. Problem is solved means we have to find P of, okay, before that, the problem solved by the student A, what is the probability? 3/4. Problem solved independently by the student B, what is the probability? 1/4. Okay. Now if they try together means when they work together, so that is the concept of intersection. Do you have some idea about this intersection? So they are doing together. So in that case, the probability of solving this problem is 1/16. Now the question is, find the probability that the problem is solved. Problem is solved means either the problem will be solved by A or by anyone has to solve, or when they are doing together. So this refers to union, refers to or, intersection refers to and, both together. Now the question is, find the probability that the problem is solved. It will be solved either by A or by B. So for that we just have to use the first formula, P of A union B, which is P of A plus P of B minus P of A intersection B. Means the probability of solving the problem either by A or by B is independent probability of A, independent probability of B. What is that? Probability of A and B both. So that is why we just use this formula there and we get it. So formula goes like that: P of A plus P of B minus what to do? P of A intersection B. So simply we just need to put the values. So P of A is 3/4, P of B is 1/4, and P of A intersection B is 1/, and then just you have to do the calculation. Okay. So this is the probability of solving a problem by uh, either by A or by the problem is solved. That means someone has to solve it out of those two students. So it is P of A union B, right? Can I start the next? Now, if I go to the second question of this type, the note, it's all about the note. Can I start? Okay. Okay, right. Question number 2. A bag, can I start the next? Number 2. A bag contains, number 2, a bag contains, so similar one example I'm taking from there. A bag contains, suppose 5 red balls, 7 black balls, and 8 blue balls. 8 blue balls. Okay. Question is, what is the probability of getting a white what's the probability of getting a red or a blue ball at random in a single random draw, in a single random draw. Okay. Now, here you see the total number of balls, You know that yesterday we discussed the denominator is always the total number of outcomes. So total, if you see 5 red balls, 7 black balls, and 8. So altogether, how many? 5 plus 7, 12 plus 8, 20. Now, probability of getting a red ball. What is the probability of getting a red ball? Red ball, how many red balls are there? 5 out of 20. Okay, 5 out of 20, so it will be 1 by 4. Now, probability of getting, what is that? A blue ball. So, blue ball is how much? 8 out of 20, right? So, it will be 2 by, no, 4, yeah. Is it 2 by 5? 2 by 5. Now, up to these two we know. Now, the question is, you see, why we have to use that particular theorem. This much you should understand. Now, we got this individual probability of getting a red, probability of getting a blue. Now, what is the probability of getting a red or a blue ball at random in a single random draw? That means we'll take only one time. So we'll take this is the bag. This is the bag, suppose, containing all these balls. We'll take out the ball only one time. Yes or no? We'll take only one ball. So it's not that when I take a ball, can I get two different colors? If I take only one ball, either I will get red. When I get red, I don't get blue. So they are independent events. That is why I gave the first note. They are independent events. Independent means this one. Independent means when A occurs, B do not occur. Getting my point? When A is there, we cannot have B. For example, at the same time, you cannot be inside the class and outside the class. You are inside the class means you are not outside the class. So when B occurs, A cannot occur. Or when A occurs, B do not occur. So here now you see, when I get A from here, when I get a blue colored ball, at the same time, can I get the red colored ball? No. Or when I get a red colored ball, I cannot get a. That is why they are independent event, and therefore the total probability, required probability, what do you have to do? What do you have to do in that case? Required probability in that case, we need to add the total. Okay, so we need to add this to get a required probability. The total number of probabilities, we just have to add P of red plus P of. Could you understand? Okay, sometimes we need to multiply also. That one I'll discuss later. So to get a required probability, just we need to add it because they are independent events. So 20 will be the LCM. This will be 5 plus 13 by 20. Okay. Right? Is it okay? So just I'm highlighting the the rules when you will add, or there is also a multiplication principle. This is the addition principle. Okay, for independent events. I'm also explaining when you need to multiply. Okay, so this is the second example. Done. Let's go for the third example. Similar type almost, but using the third note. Okay. Done. Number 3, the probability of passing in paper 3 is paper 3 of a particular student is 0.46. Question is, what is the probability that you will not pass in that paper? What is the probability that he won't pass, or he will not pass in that paper? This is the easiest one. Okay, I just have taken the example because it is there. Probability of having and probability of not having, the sum is always 1. You must have seen this somewhere. P of E plus P of not E. This is when you give a bar, it's called not complementary. The sum is always how much? Do you notice? Probability of having something and probability of not having, the sum is always 1. So if from there I write probability of not E, this bar refers to not, then it is 1 minus P of E. So this is a relation which I gave as a note. Now probability of passing in that paper means probability of yes, he will pass. What is the probability? 0.46. Now the question is, what is the probability that he will not pass? He will not pass means E bar, not E. What to do? Just minus from 1 minus P of E. Okay, so it will be just 1 minus 0.46, and what is that? 0.54. So that is the probability that he will not pass in the paper. Okay. Now, do you also know, before I start the next topic, that probability can never be greater than 1? Do you know that? Probability lies between which numbers? Probability is more than or equal to what? 0. less than or equal to 1. Probability can never be more than 1. Probability can never be less than 0. So it can be 0. It can be 0. It can be 1, but it cannot be more than 1. It cannot be less than 1. So we have some questions in school life, school syllabus. I just don't have to write it. Just you see 3/4, number 2, 7/5, number 3, 1/3, number 4, 0.006. Which one cannot be a probability here? Okay, so which your options might also come like that. Which one cannot be a probability? 2. The reason is 7/5 if you divide, yes or no? So 5 ones are 5, then 2 point, what is that? 1.4. Is it more than 1? More than 1, so cannot be a probability. Done? Is it okay? So this type of questions are there in syllabus. Okay, now before I start the next topic, I just want to write a note. I am not sure how many of you know this combination formula. NCR formula, do you know? N factorial by R factorial into N minus R factorial. Have you seen this formula before, both of you? No, you have not seen this formula before. Have you seen this? You studied 11 and 12 in science? Okay. You had maths? Okay. You also have maths? Did you have maths there? No. You have not seen this formula, right? So then let me give some idea about this formula. This formula, basically we have some formula like NPR also, but NPR questions we don't have. Permutation questions we don't have basically. So that's why I'm limiting only to NCR. Even in the textbook you can see this formula we have NCR, and I'm going to do some questions having NCR. Okay. Now those who did not know before, this is called combination. But before that combination, what this symbol means, you see, suppose 7 factorial. This is factorial symbol. Can I continue? This is factorial symbol. The factorial means, you have to multiply all the, what numbers? Say, what numbers? Lesser numbers, what? Natural numbers. All natural numbers. You cannot take decimal numbers and all. From 7 till 1, all natural numbers to be multiplied. That is what the factorial means. Is it okay? So if it is suppose 100 factorial, what will multiply? From 199 till what? Till 1. Okay. We also have some relations like this. Suppose I got it, but all of you look at this, because as some of you do not know, I have to give a brief idea about this. Suppose I have to find 80 factorial by 78 factorial. Now you might think this one so big, 80 to 1 by this rule, what you have to do? 80 to 1 by this 78 to, but directly it's not that possible, but it can be made possible. Those who know, please say what to do. 80 factorial we will do 80 into 79 into 78, because after 79 what will come? 78, 77, 76. So instead of writing all this, just we can write it 78, because after 79 the next number is what? And after from 78, 77, 76 till which number it will come? 1. So that means it is just the same number and they will get cancelled. Could you understand? So in that case you have to just multiply 80. And so why I'm saying this, while doing question right now using this, it will be required. Okay. So in that case you don't have to multiply each and every number. You just get it, the formula. That means what is, in short we can say, the bigger one we try to write in terms of smaller one. Okay. So this is the bigger, 80 into 79, then we know 78, 76, 75, so till 1. So that means it is nothing but this number only. Yes or no? So in that case you just have to keep it like that and get a required product. Now what this formula means, okay, see, before I start, this is called combination. This symbol is used for combination. Combination refers to selection. Combination refers to selection of some articles or some numbers or some items. Okay. Now suppose we have 10, you have suppose here 5 students right now. Okay, we have 5 students right now. I am suppose going to make anyone the monitor of this class, for example. So from 5, how many students we need to make a monitor? Only one. That means out of 5 we have to select. This is selection. If I like him, then okay, I am selecting him. To next day I'll take you. So it's a selection. I can select only how many students? One. So when this selection takes place, okay, then type C1. So in how many ways? In how many ways I can select the students? Look at that. See, before I give this formula, in how many ways I can select? Today I can select him, tomorrow him, you. So how many ways I can select? 5 ways. Now these ways, now let us go by the formula. So the formula goes like this: n factorial. So this is the total one. This is the total. So that way we have now 5 students. So 5 is the total. How many ways we are selecting? Taking how many at a time? Captain or a monitor, there is only one. So taking one at a time. So to use this formula, n factorial. N means 5 factorial. Getting it? Multiplied by r factorial. R means this number. What is that? 1 factorial. Multiplied by n minus r. N minus how much? 5 minus 1, 4 factorial. So 5 factorial is 5 into, I said no just now 4 factorial. 1 factorial is 1 factorial is 1. 4, this is 4 factorial. 5 by 1 how much? So that I give with example, I can today take you him or her. So we can select how many students? 5. So this is how the selection takes place, which we are going to do it now. And is it okay? So we are going to apply these formulas while particularly we talk about selection. Okay. So let me give some examples of probability containing combinations, because I can also see some questions there having this concept. So I must do few questions of this. Okay. Can I start? All right. You got some idea about this combination symbol? It is also there in the book. You can, the topic is combination. You can even search somewhere. Okay. So it is question number 4. Right. A committee of 2 persons . A committee of 2 persons is to be selected from 2 men and 2 women. 2 men and 2 women. What is the probability that the probability that the committee will have number A, no men means both will be women. Number 2, 1 man. Number 3, 2 men. Number C, okay. Done? All right. Let's start. Until you see the probability, always the total is in the denominator. Yes or no? Total, we have done all this, the total is always the denominator, whatever you have done. This number 20 is the total number of balls in this case. So a committee has to be selected. Suppose one chairperson and another one is vice chairperson or secretary or whatever it is. To be selected from 2 men and 4 women. Total how many people are there? 4 people. Out of these 4 people, we have to select how many? Any 2. So the selection can be made in this way. I give an example. I want to take these 2. or I can take U2, or I can take U2, or I can take you and her, or I can take her and you, or I can take her and you. So in how many ways two people can be selected? Getting my point? So randomly it's pretty difficult to take. It is easier right now because the numbers are smaller. But if it is 14 people, then okay, it will be difficult. That is why we cannot go by manually. Understood now? The committee has to be 2 members. So as I said, I can take her and you. I can take you and him. So in how many ways from these 5 people we can make a committee of 2. So for that, the total number of ways by which the committee can be formed is, how many people are there? Total ways, total number of ways by which the committee can be. You just have to write it in short. I am writing in details so that while doing you will not have any doubt on this. By which the committee can be selected. Okay, total number of ways. Now, how many people are there total? 2 men, 2 women. Total how many? 4. The committee, when I am selecting the members, in that committee how many people I can have? So it is 4C2. Understood? 2 persons to be selected from 4, and which 2 doesn't matter. It can be any out of those 4, right? Now question number 1, probability of getting no men. Please try to understand now. What is the probability of getting no men in the probability? That means both will be women. That means 2 women are there now, so they will only be there. Now, first of all, denominator total ways 4C2. Numerator no men. That means we cannot take these 2 people. We cannot take them. Whom to take then? Whom to take? 2 women. 2 women are there. Try to understand. From these 2 women, we have to take the 2 women only. Could you understand it? So there were 2 women, and we have to take both the women. If it is 3, then what to write? 3C2. Because 3 women, we have to take 2. Now, since the committee, why 2C2? Why this number is 2? The reason is we are selecting the committee of how many members? 2 members. That's why this. If it is a committee of 5 members and here 7 women, then 7C5. So like that. Now, I hope it is okay. So this is the probability of no men. That means both will be what? Women. Now, you just find it. 4C2. I gave the formula already. What is that? 4 factorial by, please say, 2 factorial. Again 4 minus 2. What is the formula? R factorial. So R factorial is then n minus r. N minus r means these 2 numbers you have to subtract. Yes or no? So this is 4 for 2 factorial. 4 minus 2, 2 factorial. Numerator. Any idea? This is always 1. When the numbers are same, this is always 1. I could have given a formula also. So NC1, we have a shortcut formula. NC1 is always, any idea? NC1 is always n. And NCN is always 1. You can check it. I just check it, to clarify your doubts. If it is 2C2, let us find it. If it is 2C2, n how much? 2. R is also 2. Then n factorial. N factorial means 2 factorial. Then r factorial. What is that? 2 factorial. Then n minus r. 2 minus 2. How much? 0. Now 2 factorial got cancelled. And you please keep a note. Okay, it is elaborately explained in the schooling class. 0 factorial is considered as 1. So here 1 is left. 0 factorial is not 0. Because if it is 0, it will become something not defined. So 0 factorial is always considered as 1. That is why, what is the answer? 1. So you keep a note of these 2 also, shortcut, or the derive 1 from this formula. NCN is always same number, these 2. Then 1, NC1 is n. So that is directly 1. So I can write it now. I believe I can write this is equal to 1. So you do the calculation now. It will be 1. Now say 4 factorial is how to do? 4 into 3 into 2 factorial by 2 factorial, 2 factorial. 1, 2 factorial will get cancelled. Are you getting my point? I'm trying to do directly. This 2 factorial we have to expand. How? 2 into 1. 2 and 2 will get cancelled. What is the answer? 1 by 6. Okay. Got it now? Now, can you say this answer will be similar to which one? 2 men. It will also be similar to 2 men. I am erasing after some time. Probability of 2 men means both will be what? This question is all about the committee members that is formed for 2 men and 2 women. Now they are talking about 2 men. That means both will be men. Here what is that? No men. That means both were women. Here now both will be men. How many men were there? 2. So from 2 men we need to take 2 men only. 2C2. Here denominator. There are 4 people. We can select the committee in. Our answer will be same. Okay. So 1 and 3 is same. So this will be the answer of also 3. P of what? 2 men. Okay. Now please keep a note. And that is what I said few minutes back. I am going to explain you how this multiplication principle can be applied. Okay. So I just did for addition principle. Now I am going to explain number 2. Probability of 1 man. The committee is having how many members? 2. But we will be taking, that means what the other member? She will be a what? Woman. I repeat. The committee committee already have 2 persons. We will be taking how many? 1 man. That means the other one must be woman. Okay. So before I continue the numerator, denominator is same, 4C2. Because 4 people, 2 persons to be taken in 4C2 ways. Yes, please try to answer. How many men were there? 2. So from these 2 men, how many men they are asking us to take? So it will be 2C1. But is the committee completed? No. Why? Because only 1 man, the committee must have how many people? Then what we will take? One more woman will take. From where? From the woman only we will have to take now. So from the other 2 remaining women, we have to take 1 woman. Is it clear? Is it okay? Yes. Now finally, I said I am going to explain the multiplication principle. Here you need to multiply. Now you can have a question, those who did not know before this concept, why multiplication? So before that, why multiplication? You will look at this example. While doing this question, I said we have to add. The reason is they are independent. Independent in the sense, as I gave the example, if I get blue, I do not get. If I get red, I do not get. But in this situation, okay, so when independent, we have to add. When dependent, we have to multiply. Now, how to understand dependent? Now, this situation is a dependent situation. So, dependent situation, we have to use the. Now, how can you understand dependent? Because as I have taken 1 man, how many men taken? So, how many women I need to take more? So, what number is taken here? This number is dependent on that. Could you understand? If I take one man, can I take here 3 women? No. This one woman is dependent on 1 man. Why? Because total altogether, how many people should be there? So, here the second situation is depending on the first situation. I think it is okay. How many, just a minute. Yeah. So, how many women we will take? It depends on this number. Because we have taken 1 man, means we must take only 1 woman. As the total must be how many? 2. See, if you understand this, any question of this, this time we can do it. So, if it is suppose 3 persons, then here 1. Well, how much you have to take here? 2. So, this number is completely dependent on this. So, when it is dependent situation like this, second number, when it is dependent, we need to multiply. Dependent situation, this is called multiplication principle. Okay, I think it is okay now. Clear now? So dependent situation, you will just understand the question. So you don't need to understand this, that okay, this is a dependent question or independent. Dependent means multiply, not depending on each other, directly add. Okay, So it's directly 2C1 you have already done how much? 2C1 is 2. Again 2C1 is 2. 4C2 we did before. How much? Was it 1 by 6? Yeah, 1 by 6. Four C2 is 6, sorry. 4C2 is 6, yeah. 4C2 is 6. That's what I'm thinking. So 4C2, this is the calculation for 4C2, no? How much we got? 6. So it is 6. That means what is the answer? 4 by 6 means 2 by 3. So your exams, all the question doesn't come. Any one will come with the option. So 2 by 3 is an option. So like that we can have some other options. I think it is okay. So I give you more example. I'm going slightly to difficult one. Can I start the next? Okay. So slightly difficult one about the cards. I think number 5. Okay. Find the probability that, please write. Find the probability that when a hand of 7 cards are drawn. Here I won't do the calculation. I'll leave the calculation for you. I'm just explaining that. Formula you already know how to find it. Find the probability that when a hand of 7 cards are drawn, from 52 playing cards. That day in the last class we discussed about the playing cards, 52 playing cards. So those were there, I believe you know the categories now. From 52 playing cards, okay, find the probability that okay, find the probability that when a card is this, all cards, sorry, this line is already written, that it contains number A, all kings, number B, 3 kings. Or I'm changing it to suppose 3 queens. Can I start? Okay. Number 1. I'm writing this directly. Total calculation, I hope you can do that. So probability of getting all kings. Probability of getting all queens. You'll try the second one yourself, okay? Right now. Calculation I'm not doing, and we are also not doing right now. You know this formula, NCR formula. So just you need to apply that formula. Okay. Now, yesterday when we discussed that there are 52 playing cards. 52 playing cards. So from 52 playing cards, how many cards are drawn? Not one by one. Total with a hand off. That means like that. When drawn, how many cards are coming out? 7. So total, how many ways it can be done? From 52, how many cards are taken? 7. Now why 52C7? Because I can take this 7 or some other 7 or some other 7 cards. Yes or no? So in how many ways it is possible? 52C7 is. That means 52 cards are there now. So I can take this 7 or that 7 or. So in how many ways it is possible is this number. Okay. Now look at the first one. Numerator is confusing. Now when you get the 7 cards, please try to understand this. When you get the 7 cards, in that 7 card, all kings should come. Do you remember yesterday how many kings are there in all? How many kings? 4. Do you have any idea about you were there yesterday? Okay, do you have any idea about the cards, playing cards? Okay. So total how many king cards are there? That means out of the 7, all kings should be there. How many? 4. How many extra cards should be there? 3. That only 4 plus 3, 7. Yes or no? Now 4 kings we need to get. From how many kings? From all the 4 kings, we will get all the. Alright, could you understand? There were 4 kings in these 52 cards. If in these 52 cards 10 kings are there, listen to me, then you have to take 10c, 10. Now that all kings, no? Yes or no? So there are 4 kings, so you have to take all the 4 kings, right? Into. I'll tell you why into. Now try to answer. These 3 cards, why 3 cards? Because then only 4 plus 3 will be 7. So these 3 cards we need to take from where? These 3 cards we need to take from the remaining. What is the remaining? 52 minus 4. What is the remaining? 48 C2. Could you understand? C3, sorry, 48 C3. Why 48 C3? Because from 4 kings, all 4 kings are taken. Total how many cards we are asked to take? 7. Yes or no? So 7 means here already 4 are gone. Here already 4 are gone. How many left? 3 left. Now these 3 we need to take from the remaining. 52 cards are there. 4 kings were there, minus how many? So from these remaining 48 cards, we need to take 3. So this will be the answer. Calculation, I hope you can now complete. Okay, so I'm not doing the calculation, or let us not do the calculation. Just let us go only by the conceptual part. Okay, now second part. Try the second one. Try the second one. Here, almost similar. Almost similar. Number B. What is that? Probability of 3 queens. Probability of getting 3 queens. Try. Similar. How many queens are there? 4. We have to take how many? 3. Okay, do this. Coming? 4. So, denominator same. 52 cards. Yes or no? 52C. 52C. 7. Numerator. Is it 4C3? Why? There are, keep saying, there are 4 queens. Out of 4 queens, 3 queens are taken. How many remaining cards? 48. From this 48, what to take? How many? 4. Achha, why multiplication? Because this 4 is dependent on 3. It was 4, so 3. Because the total must be how much? 7. So that is a dependent situation. Achha, one thing you tell me. Is it 48 or some other number? Because we took only 3 cards. Can it be 49? 49 or 48? Huh? 40? It cannot be 49. The reason is, if it is 48, then one king card will come here, no? That king might again, sorry. One queen might come, so one more queen will come, then in that case the question will not be satisfied. Because we are asked to take only 3 queens. So, if this extra card is added here, it will become 49, that is okay. What is not okay, from that again one more queen will come, so in that case, how many queen will be there? 4. But the question is only for 3 queens, okay. So calculation, you will do it. Alright, write the next question. Now you will understand the difference between that question and this, okay. A letter is chosen, everybody will try this question. A letter is chosen at random. A letter is chosen at random from the word a letter is chosen at random from the word. Now you'll be able to correlate what you have learned in your other classes and what you're learning, because those who did not get, combination concept, assassination. A letter is chosen at random from the word assassination. Find the probability that it is a vowel. Find the probability that it is a vowel. Number B, it is a consonant. Okay. A letter is chosen at random from the word assassination. Okay. Find the probability that it is a vowel, it is a consonant. All right. Let's start the first one. P of vowel. Number A. P of vowel means probability of getting. You have to write direct answer, no? So your statement doesn't matter. Yes. Total in how many ways? See, A letter is chosen. The last question, 7 cards were taken. So 52, C, 7 or whatever. Now how many? Only one letter is chosen. Out of how many? You see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Am I correct? So from 13, how many to be chosen? 13C1. Is it okay? 13C1. What is chosen? Vowel. How many vowel? How many vowel are there? You find it. So 1. Repetition also there, you have to count. 2, 3, 4, 5. Out of these 6 vowel, how many letters are chosen? What do you have to write? 6C, 6C1. Okay, fine. 6C1 is how much? NC1 is, I give this just now. NC1 is what? N. So 6C1 is 6. By what? 13. Okay, done. I have to explain something additionally. P of consonant. P of consonant. Okay, I think very much direct. Total is how much? Out of 13, 1 is taken. Okay, if 6 are vowel, how many are consonant? So what do you have to take? 7, 7C. What is the answer? 7 by. Okay. Now, actually, what for I took this question, try to understand. If this question, we do not do this part, nothing wrong. Total, how many letters are there? 13. How many vowels are there? I repeat. Total, how many letters are there? 13. I'm saying if I don't do this part. Total, how many vowels are there? 13. Sorry. Total, how many letters are there? No, 13, yeah. How many vowels? 6. We can do directly. Why can't we do directly here, you know? If more than 1 is taken, then this combination must be used. 7 cards you draw, 2 cards you draw, 5 cards you draw, you should use the concept of why, you know, up to class 10 you did not get this. Those who studied 11, 12 or, you know, statistics and all, you have some idea. When more than 1 card is drawn, then combination to be used. I started today directly combination. Now I'm correlating what you have learned in class 10 and doing today. When only 1 is taken, if I use the same concept, no use. In class, up to class 10 in school, what did you get? You know, a letter is chosen, a person is taken, a card is chosen. Every time was a, only 1. That's why 61 is what? 6. So in school, up to 10, what I have done? Oh, total here 6 vowels, we wrote in favorable. Total letters were 13, we wrote 13. Because every question up to 10 was a letter chosen. Okay, so similarly consonant, how many consonants are there? How many consonants? 7. Out of how many letters? So we can write directly. Now tell me, when you will write directly? This way. When the chosen, whatever is chosen, whatever is drawn, whatever is taking out, if it is only 1. If it is only 1, then direct method like this. If it is direct method means direct counting only counting. Okay, what you have, if it is more than one, if it is more than one, 2 cards are taken, 5 cards are taken, 13 cards are taken. So if it is more than one, you always use the combination or concept of combination. Hope it is okay. All right. So now see why I take this question, particularly this, so that now when you revise from the book, okay, 7.2, okay, and also you see in the later pages you have the more question of combination. So when you use this now, you'll be able to find out. For example, page number 410, 411, there are so many questions of combination. Means probability with the help of, getting my point? 410 you see, 410, 411 you see, every time many questions are there of C. So when to take C? More than one if it is taken at random, yes or no? So you'll go through these questions. Just to clear this concept, I took the example of both, right? All right. So tomorrow, means the next class, I'm going to start the conditional probability. Okay? Nothing wrong if you take it like that, but it's a wastage of time, yes or no? So next class, I'm going to start conditional probability, and in another 4 to 5 classes, I'll complete the syllabus. Okay? Thank you.